let's talk about a couple more alternative energy sources. Let's talk about wind and water. So wind is energy generated from the kinetic energy of moving air. Little physics, all right? Energy is stored in different ways. And we can harness that in different ways. Things that are moving have energy, called kinetic energy, right? If you're standing there and I run at you and hit you, I'm hitting you with a lot of energy. Why? Because I'm moving. There's nothing different about me. It's just that I'm moving. So there's something called kinetic energy in things that are moving. Energy that's kind of stored in these moving things. So if air is moving, it has energy, it has kinetic energy. So what we can do is take that moving stuff to move other stuff. So take the energy of the moving stuff, wind, to move other stuff, to generate electricity. So wind energy is the fastest growing major source of electricity in the world. It's not a lot, but it's the fastest growing percentage-wise. As far as capacity is concerned, the U.S. has a decent amount of capacity to utilize wind, but we just don't generate that much from it. We could do more probably, but we just don't do much with it. For instance, Denmark, they only have the capacity to do a little with it, but they, percentage-wise, do as much as they can, or they do a lot. All right, so it kind of shows you again the discrepancy there. So how do we generate electricity from wind? That's really the how we harness that energy, is generate electricity. So we have these big fans known as turbines. So the turbine converts wind energy into electricity. So the blades of the fan are spun by the wind. The turbine is connected to a generator. So when you spin the turbine, the fan blades, the wind spins the fan blades, it spins a generator, the generator spins, generating electricity. Very simple. Wind turbines on land are typically installed in rural locations, away from buildings, away from population centers, very common in flat areas or mountain passes, kind of the tops of mountains where wind can be channeled. You know, you don't typically have a bunch of turbines in the city. Wind or buildings, houses can block and alter a lot of that. So wind farms, again, are usually out in the middle of nowhere, in flat areas. Think in the middle of like Kansas where it's flat and, you know, farm areas and the wind can kind of race through there, or on tops of mountains in mountain passes. I know if you're driving on the 10 from here to California and you go up and over some of the mountain passes in like Palm Springs, that's where you tend to see a lot of these wind farms, again, up on mountain passes where the wind can be kind of channeled and funneled. Turbines usually aren't on their own. Sometimes they are, but typically they're grouped into wind farms. So again, the wind comes, spins the fan blades, the turbine's connected to a generator, spins the generator creates electricity. Pretty simple. All right, there's nothing you need to burn, because again, with fossil fuels, we're burning them to generate steam. Steam spins the turbine, which spins the generator, which generates electricity. Here, it's right to the point. The fan is the turbine itself. The wind spins the fan, spins the generator, generates electricity. The fan blades can tilt. The top of it can also change as well, so it can harness the proper direction. So the advantages, it's non-depletable, right? It's a renewable source. The wind's the wind as long as the earth exists. It's a free energy source. The wind's going to do what the wind's going to do. After manufacturing and installation, there's really little energy input other than wind is required. It produces no pollution, no greenhouse gases. And great thing is that wind farms can share land with other uses. So where solar panels are, you know, that's typically it because you're covering the ground. But with wind, you have these big turbines on poles. You can still have a farm. You can still have things around. You know, the land can still be utilized somehow, some way. Disadvantages. Well, they don't work when there's no wind. So that's why these are typically only in places that are windy. They can be unattractive to some people. I don't know. I know anytime I drive by them, I'm fascinated. Like, oh, wow, look at those things. To me, it's very fascinating. So, you know, these are big fan blades moving relatively fast. You can hit birds. As many as 40,000 birds are killed by wind turbines in the U.S. each year. Bats are also kind of thrown in here if it's windy at night and they're flying through. So some people that are, you know, birders are concerned with that. You know, they have some issues, but I don't know, I think they're kind of cool to look at. So here's is a great example of a wind farm kind of up on a mountain pass. So you can see up on the tops of mountains as that wind kind of goes up and over, gets funneled in, squeezed in that atmosphere, spinning these turbines, which spins the generator, which generates electricity. I don't know, again, I think they look kind of cool. They're kind of fascinating to me. So that's wind. What about water or hydro? This is energy generated also from the kinetic energy of moving water. So in this case now we have moving water, which has kinetic energy. So we use that moving water to move something else to generate electricity. So main ways of generating hydroelectricity. So using moving water to spin turbines that spins generators that generates electricity. The main ways of doing that are using gravity dams or something called run of the river, as well as tidal technology. In all of these cases, we're using moving water to spin turbines, and those turbines are connected to generators. The turbine spins the generator, generates electricity. Catching on? So gravity dams, these are kind of the big dams that we think of, like the Hoover Dam. So you have all this dammed up water. And so the further down you go, the more it increases in pressure. So the intake of dams are kind of down below. Each dam is different depending on where that intake is. Well, that water under pressure surges through the intake valve, spins a turbine, which spins a generator, which generates electricity. Sound familiar? And again, the water then comes out the outflow out the other side. Typically, you'll have a number of intakes and a number of generators generating electricity. So here's the Hoover Dam. The issue with water concerns now, especially in the desert Southwest, is that pretty soon there's not going to be enough water behind the Hoover Dam to generate electricity, because you need more water to generate more pressure to go flow through to spin the turbines. Less water, less pressure through the intake, the less the turbine spin, it won't generate electricity. So as water behind the Hoover Dam drops and continues to drop in Lake Mead, they're going to lose out on electricity. A lot of this electricity goes to Las Vegas. A lot of electricity generated here. So here's another one. This is the Grand Coulee Dam up in Washington. A very large dam, but again, the same purpose. And here's all these buildings are where the generators are located. So the intakes are down below. You can see the water coming out. It looks like this is the main generating station here. This is almost a mile long. It's huge. Absolutely huge. You also have something called the run of the river. So again, you're just utilizing moving water. So the river goes this way. Well, what you can do then is kind of just take a little slice of that river, kind of get it going in a pipe, spinning a turbine, which spins a generator, which generates electricity. So you're not utilizing the whole river, just a little bit of that river, called run of the river. So instead of using kind of the whole river, you can just use a little piece of that river to generate electricity. Run of the river. So yeah, you're not using the whole river, you're just using a little piece of that. It's like the main river kind of goes this way and maybe back around. You're just using a little slice of that river. Run of the river. And then the third type of way to utilize moving water is tides. Using tides. Tides rise and fall naturally along the coasts. All right, in the oceans. That's due to the gravitational pull of the moon and the sun as we go around the sun, and as the moon revolves around the earth. The gravitational pull pulls on everything, including water, which causes the tides to rise and fall. If you've ever been to the beach on the ocean, you can go in the morning and the water's kind of way up close, and you can go back in the afternoon. The water's way far out. You can walk way out far to the water. It went out. Tides rise and fall. Well, as the tides rise, that's water rushing in. As tides fall, that's water rushing out. Moving water. You put some turbines in an area where there's a good fluctuation of tides. As that water is rushing in, spins the turbines, spins those fan blades below the water, which are connected to generators, generates electricity. As the tide falls and the water rushes back out, the fan spins the other way, also generates electricity. So you can do that with like kind of these single posts that have these large turbines below. You could also have kind of tidal dams in which basically serving the same purpose, but you're kind of slowing up some of that water. As the ocean rises, that water comes in, you kind of close it off, and then you release that water. You release that water through the turbines to kind of generate electricity. And the reverse, when the high tide rises, it kind of rushes back in. You kind of slow it down and dam it up this way, but you're still using tides, the motion of tidal water through a turbine to generate electricity. So here's one of those below water tidal turbines. They're pretty big, right? They're pretty big. So you have to have a pretty decent depth down below in order for these tidal turbines to work. So you can see that this kind of raises and lowers, so you can kind of work on it a little bit. And then depending on the height of the tide, you can raise them and lower them so they are within the tide itself. But you do need kind of a deeper channel. But again, you're using water moving, the kinetic energy of moving water to move something else, in this case, spin a turbine to generate electricity. Here's one of those tidal dams. As the water rushes in, kind of close it off, let the water trickle back out through the dam, which spins turbines as it's moving out. So, what are some advantages and disadvantages of utilizing water as an energy source? Well, you can bring renewable energy to a large number of rural residents, especially along coasts, obviously. It does not create pollution. It does not create waste products. It does not create CO2. Electricity generated is typically less expensive than some of those other ways of generating electricity that are also alternative. Nuclear, much cheaper. Or hydro is much cheaper than nuclear, much cheaper than solar. Can be much cheaper than wind, but I think that's kind of changing. You can also, behind these dams, behind the Hoover Dam, you're creating this large lake. It creates recreational opportunities for boating and fishing and water skiing and all kinds of fun stuff. But, disadvantage, for example, if you're creating large dams, that reservoir behind may flood agricultural land that was once there, may flood archaeological sites that have significance, force people to relocate it because, you make this dam, and if you're raising the water level behind it, well, then anything that's lower in elevation is going to be covered by water. It's something we got to think about. If you are impounding a river, for instance, run of the river, or somehow channeling the river, you can interfere with organisms that depend on a free-flowing river. So if we're damming up, for instance, the Colorado River, the Hoover Dam, well, if we make that dam, then the fish that used to swim upstream, well, they can't do it anymore. So you're interfering with the river organisms and the river ecosystem, which can not only affect things upstream, but also downstream. So you are impacting the environment. So those are the 4 different energy sources. We're not quite done with this section, so we're going to pause here. When we come back, we'll kind of put all this together, and then we'll kind of shine a spotlight on Arizona. See you back here in just a second.